First of all, what's the name? These are almost identical to linear equations. In other words, that whole thing we talked about, we just did with the slope-intercept form, with the standard form, holds true for this. Except, okay, instead of these things being x equals or y equals, it's y is less than or greater than. Okay, so they're done the same way with a few exceptions. Okay, they're, oh, solid. A little bit of shading going on there. Yeah. First thing to know is this. Let's just say we're graphing this equation or inequality. Okay, it's the same thing we just talked about. You can graph it with slope-intercept. So that means this one is going to cross the y-axis at -3. Can you get bigger there? Yeah. So you can still put your dot right here. Okay, it still has a slope of, Charlie, what's my slope here? 2. Is it positive or negative? Positive because there's no negative in front of it. So that means it goes up 2 over 1, up 2 over 1, up 2 over 1. Okay, here is the first difference. Okay, write this down. I'll write it down here. If it is equal to, that means if you have a less than or equal to sign, like this does, okay, it's going to be a solid line. Okay, so just like linear equations, you are going to get the same line. Mine's actually going to draw it here. The same line, and it's going to be solid. Well, if I told you that it's going to be solid, you can probably guess that there's going to be times when it will be dashed. Okay? Oh. If this equal sign, if that equal sign would not have been there, if it would have just said y is less than, then rather than being a solid line, it would just be a dashed line. And look like this. Okay, so we probably should write that down. If it is not equal, it's a dashed line. Okay, if there is no little line under the inequality that says it's equal, it's going to be a dashed line. Otherwise, it's going to be a solid line. Now I'm going to get rid of all that because it is equal to. And then I'm going to have you think about this. He's got a lot of places to be. Think about this, children. Let's think about this. If y is less than or equal to 2x minus 3. If I asked you to make a table of the values that work for this, okay? If I asked you to make a table of the values that work for this, and I put a 1 in for x, what would y be? 2 times 1 is 2, negative 1. But y wouldn't only be negative 1 because I'm now asking that says y is less than negative 1 or equal to negative 1. So y could be negative 1, but it could also be anything less than negative 1. It could be negative 2, negative 3, negative 4, negative 5, negative 6. Any of those work because they're all less than negative 1. So here, where x is 1 and y is negative 1, not only does that dot get colored in, but really you have to color in all the dots that fall below it. Okay, same thing for 0. If I put 0 in for x, y equals negative 3, but it's not only negative 3, it's anything less than negative 3, so you have to color in.
So we're going to have a bunch of dots on the thing?
No. Of course we shade it. In this case here, your graph will look like this. And here's the other point you have to look at. Since this is y are all the values less than, you shade everything that is less than that line on the y-axis. And I will tell you, listen carefully, the point where most people get confused is they don't know what side of this line to shade, the top or the bottom. It all depends on the less than or greater than sign. If it is y is less than, you're going to shade all the things where y keeps getting smaller, the bottom of the y. If this would have been a greater than sign, I would shade everything on the top. So you just have to look at that y in the less than or y in the greater than. If it's y is less than, everything on the bottom gets shaded. Okay? And that would be the graph of y is less than or equal to 2x minus 3. Taylor?
Where did the little dots come from?
Well, you don't really need to know about the little dots. That was just telling you why you shade.
So when we have a problem like that,
You won't do little dots.
alright, but when we get a problem like that, we're just gonna draw one line and then we shade in the part,
You're gonna draw this line and then you'll shade and it'll be over.
and then if it goes the opposite way, then we shade in the other.
Right. Now, but with that being said, there are a couple special cases. This is one, okay? This is one. This just says x is greater than 5. And again, here's the deal if you think about this. You don't have to make the table, but the table helps us think about this. If I make a table, okay, it doesn't matter what y is, x always has to be greater than 5, okay? So I can put any number for x as long as it's greater than 5. So give me an example. Actually, give me a number greater than 5. 6, and then y can be anything, so give me any number.
24.
1.
Give me another number greater than 5.
7.
Y could be
2.
2. Well, now we're getting a pattern here, but let's say x is,
9.
well, x could be
500.
5.5, and y could be 0. Okay? How do I show that on a graph? Well,
Infinity.
x is 5 right here. Okay, since there's no equal sign at that, it can't equal 5, but it starts at 5. There is going to be a dashed line here at 5, and we know that x has to be anything that is bigger than that, so x can be anything to the right of that. So this is the only time you're going to have a vertical line, is when you get an x equals problem. So this side over here, it doesn't matter what y is, because y can be anything, but x has to be anything bigger than 5. So any point I pick in this shaded region would work. If I pick this point right here, this point is x is 6, y is negative 2. Does that work? Yeah, because the only thing it has to be is x is greater than 5. I think if it's a y problem, like which one? What's problem 3 on there?
Y is less than or equal to 0.
Take a look at this. Y is what?
Less than or equal to
Less than or equal to 0. Okay. That means y can be anything. Y can be anything that's less than 0, and x can be anything. So there's an equal sign. So here where y is 0, which is right here, you draw a solid line. It's actually the x-axis. And then what am I going to shade? Anything below it, because y has to be less than 0. So I'm going to summarize that for a second here. I had that drawn on my thing and I don't know where it went. Hold on. Well, and then tomorrow we do equations of linear inequalities.
Oh, okay. More,
Let's do some like acting. I was watching.
So let me throw that at you again, so that so you don't. The two special cases are when x equals and when y equals, or greater than or less than. So this. Let's do just a couple. Let's say I've got,
Number 4.
no, let me just do new ones here. X is greater than or equal to 3, and x and y is greater than, let's say, 4. Here are the quick graphs of this. This is what the graphs of those will look like. Okay. If it's an x by itself thing, that means it's going to be a vertical line. Where's the vertical line going to be? At 3. X is 1, 2, 3. Is it going to be a solid line or a dashed line?
Solid.
It's going to be a solid line where x is 3, and you're going to color in anything that's greater than that. So it's going to go this way. If it's an x by itself with a number, it's always going to look like this. It's going to be a vertical line, and you're going to color in one side or the other. Had this been this, had this switched and been a less than sign, sorry, that means you color in the less than side, which would be this side, where x is smaller than 3. Greater than side, less than side. Y's are very much the same, except they're not horizontal, they're not vertical lines, they're horizontal lines. At where y is 4, 1, 2, 3, 4, it's a dashed line because it's not equal to 4, but it starts at 4. Am I going to color in the what side am I going to color in, the top or the bottom?
Top.
Y has to be greater, so the numbers have to keep getting bigger for y. So you're going to color in the top side. Y has to be greater than those numbers. Joshua's y is less than, then you color in the bottom. Okay. Now, the third problem, number 4. Problem number 4. First thing you look at is it equal to?
No.
No, so it's going to be a dashed line that you draw. Graph it just like a linear equation. What's the y-intercept? -1. What's my slope?
Down 5 over.
Down 5 over 3. It doesn't matter. 1, 2, 3, 4, 5. Positive or negative slope?
Negative.
Negative, so I'm going to go 3 this way. Or up 5. 1, 2, 3, 4, 5 over 1, 2, 3. This has to be a dashed line, and I'm going to draw it freehand because I want to take the time with it. It's a dash because it's not equal. And here's where people run into trouble. Am I going to shade this half, or am I going to shade that half? Y has to be
The top half.
less than.
The top half. Bottom. Bottom. That's bottom.
So it's where y keeps getting smaller, which would be the bottom half of this graph. Y keeps getting smaller going this way. You only look at where it crosses going down. Don't look at, because you'd say, well, y is up here, but it's down here. So this is your graph of that linear
Or
inequality.
change the sign on the top.